Hello, welcome to this new channel, the ASMR Egg. Today I'm going to be talking to you about algebra. So, what is algebra? Algebra is a branch of mathematics dealing with symbols and the rules for manipulating those symbols. In elementary algebra, those symbols, today written as Latin and Greek letters, represent quantities without fixed values, known as variables, just as sentences describe relationships between specific words. In algebra, equations describe relationships between variables. Take the following example. I have two fields that total 1,800 square yards. Yields for each field are 2/3 of a gallon of grain per square yard and half a gallon per square yard. The first field gave 500 more gallons than the second. What are the areas of each field? It's a popular notion that such problems were invented to torment students, and this might not be far from the truth. This problem was almost certainly written to help students understand mathematics, but what's special about it is it's nearly 4,000 years old. According to Jacques Sechano, in an introduction to the history of algebra, this problem is based on a Babylonian clay tablet circa 1800 BC. Since these roots in ancient Mesopotamia, algebra has been central to many advances in science, technology, and civilization as a whole. The language of algebra has varied significantly across the history of all civilizations to inherit it, including our own. Today, we write the problem like this. X plus y equals 1,800. 2/3 plus x take away 1/2 plus y equals 500. The letters x and y represent the areas of the fields. The first equation is understood simply as adding the two areas gives a total of area of 1,800 square yards. The second equation is more subtle, since x is the area of the first field, and the first field had a yield of 2/3 of a gallon per square yard. 2/3 take x, take 2/3 times x, represents the total amount of grain produced by the first field. Similarly, half take y represents the total amount of grain produced by the second field. Since the first field gave 500 more gallons of grain than the second, the difference, hence subtraction, between the first field's grain, 2/3 take x, and the second field's grain, half take y, is 500 gallons. Of course, the power of algebra isn't encoding statements about the physical world. Computer scientist and author Mark Jason Dominus writes on his blog, The Universe of Discourse. In the first phase, you translate the problems into algebra, and then in the second phase, you manipulate the symbols almost mechanically until the answer pops out as if by magic. While these manipulation rules derive from mathematical principles, the novelty and non sequitur nature of turning the crank or plugging and jugging has been noticed by many students and professionals alike. Here, we will solve this problem using techniques as they are taught today. And as a disclaimer, the reader does not need to understand each specific step to grasp the importance of this overall technique. It is my intention that the historical significance and the fact we are able to solve the problem without any guesswork will inspire inexperienced readers to learn about these steps in greater detail. Here is the first equation again. X plus y equals 1,800. We solve this problem for y by subtracting x from each side of the equation. Y equals 1,800, take x. Now we bring in the second equation. 2/3 take x minus 1/2 take y equals 500. Since we found 1800 take x is equal to y, it may be substituted into the second equation. 2/3 take x minus half times 1800 take x equals 500. Next, distribute the negative 1/2 across the expression 1000 take x. 2/3 plus x plus minus half times 1800 plus minus half take x equals 500. This simplifies to 2/3 take x minus 900 plus half take x equals 500. Add the two fractions of x together and add 900 to each side of the equation. 7/6 plus x equals 1400. Now divide each side of the equation by 7/6 times equals 1200. Thus the first field has an area of 1200 square yards. This value may be substituted into the first equation to determine y. 1200 plus y equals 1800. Subtract 1200 from each side of the equation to solve for y. Y equals 600. Thus, the second field has an area of 600 square yards. Notice how often we employ the technique of doing an operation to each side of an equation. This practice is best understood as visualizing an equation as a scale with a known weight on one side and an unknown weight on the other. If we add or subtract the same amount of weight from each side, the scale remains balanced. Similarly, the scale remains balanced if we multiply or divide the weights equally. While the technique of keeping equations balanced was almost certainly used by all civilizations to advance algebra, using it to solve this ancient Babylonian problem is anachronistic, since this technique has only been central to algebra for the last